This is the intro video for Algebra 1 for adding and subtracting radicals. All right, so as a way to kind of help us understand how this works, I thought I would remind you of something we have done in the past, and that is adding like terms. And so that would be what's going on over here. So what we're going to do today is really similar to this. If you remember, if you have an expression like 3x plus 5x, you recognize, of course, that those are like terms because they both have an x to the first. And then what you do is you add the coefficients. So 3 plus 5 is 8. And then the x just remains an x. So it would be 3x plus 5x is 8x. And literally you have 3 x's and you're adding those to 5 x's. How many do you have? You have 8 x's. That's all it really means. So then on the right, we have a pretty similar looking expression. Just please note that instead of an x, I've written root 2. And so we're going to look at these as like radicals or like radical terms. So since both terms have a root 2 as a radical, we're going to really approach these in much the same way that we would approach the like terms that we just added. We're going to recognize that these are like radicals. They both have root 2. So we'll add the coefficients. 3 plus 5, of course, is 8. And the radical remains exactly the same, 8 root 2. If you wanted to in your calculator, you could check this. You could type this into your calculator and see what the calculator tells you the approximate value is, and then do the same thing with this. And I think you'd find that they really are exactly the same. Okay, so we're going to do a couple of examples here. The first one is number 1. And I encourage you, if you feel like you got the hang of this, pause the video, try it on your own, see how it goes. All right, so simplify if possible. So please notice that the two radicals are the same. So these are like radicals, just like we had like terms before. So that we handle this is we add the coefficients. 4 plus 6 is 10. We leave the radical the same. We end up with 10 times the square root of 7, or 10 root 7. All right, for number 2, it says simplify if possible. So what we're going to do here is we're going to look at the two radicals. I've got root 5, and I've got root 5x. And what I've got to recognize here, of course, is that root 5 and root 5x are not like radicals. And there's nothing I can do to simplify or change those. And because those radicals are not like radicals, x root 5 plus x root 5x is the simplest version of this answer. There's really nothing I can do. Can't simplify it, so leave it alone. Number 3. Now we've got 3 radicals, and so I've got root 11, root 21. Okay, so here I need to look and decide if I've got like radicals or not. Please notice that these two are like radicals. They're both root 11. The root 21, of course, is not like the root 11, and there's nothing I can do to simplify it. And so I'm going to leave that one alone, but I can add those first two. So what I'm going to do is add the coefficients. 3x minus 6x would give me negative 3x. I leave the radical alone, so it would be negative 3x root 11 plus x root 21. And again, I just confirm here that these two radicals are not like, and so, and of course they aren't. And so that's the simplest I can make this. This would be my final expression for number 3. All right, hope that went well. See you in class.